Hi, sixth graders. Today we're taking a look at lessons 10 and 11. We're going to put them together. We are going to start on page 96 in your book. We're skipping that first intro. So let's take a look on 96, and it says, write one inequality statement to show the relationship among the following shoe sizes. And there's 3 different shoes. And we have an A and a B. So we need to label these or fill them out from least to greatest. Well, we know, what does least mean? Yeah, least means the smallest. So what's the smallest shoe size? 8. And 8 is less than the next one, which is 9. And that is less than 10.5. And now going the other way, B says the greatest to the least. Well, 10.5, do I use that same sign? No, I have to flip it because it's greater than 9, and 9 is greater than 8. Okay, so notice that depending on where the integer is, we have to make sure we're using the appropriate sign. Now looking at example 2, it says, Mary is completing the rainfall totals for May, June, and July. The data is reflected in the table below. Fill in the blanks below to create inequality statements that compare the changes in total rainfall for each month, the rightmost column of the table. Well, what does rightmost mean? Okay, rightmost means the column at the very far right. So we're going to be taking a look at this table, and we're looking at this column here at the end. And it says write an inequality to order the changes in total rainfall. Now again, we want the least to the greatest. Well, which one of those is the smallest amount of rainfall? Okay, the smallest amount. Negative 1.4 is smaller, you got it, than 0.3, which is smaller than 0.5. If we're going from the greatest to the least, we're going to have to flip it around, right? So we're going to have 0.5 is greater than 0.3, which is greater than negative 1.4. Now, it says down below, in this case, does the greatest number indicate the greatest change in rainfall? This is our biggest number, right? Is that the greatest change in rainfall? No, it's not, right? No. 1.4, okay, negative 1.4, oh, we can't have negative, so 1.4 inches, okay, is farther or larger change, okay, than 0.5. And what I mean by that is there was almost an 1.5 inch difference in the amount of rain for this part, and there was only a 0.5 inch difference of rain in the second number. Let's go ahead and look at number 5. On number 5, it says, Mark's favorite football team lost yards on 2 back-to-back plays. They lost 3 yards on the first one, and then they lost 1 yard on the second one. Write an inequality statement using integers to compare the forward progress made on each play. Well, what are the 2 numbers we have? Lost 3 yards, negative 3, and lost 1. So we're going to compare those. You can write them in any order. Okay, so I'm going to just put negative 3, negative 1. Is negative 3 larger or smaller than negative 1? It is smaller. So we're going to go like that. That's it. Sierra had to pay the school for 2 textbooks that she lost. One textbook was that much money, $55. The other one was $75. Her mother wrote 2 separate checks for each one of them. Write the 2 integers that represent the change to her mother's checking account. Then write an inequality statement that shows the relationship between the 2 numbers. So the first thing we have to do is we have to write integers that show her change. So how do we write this textbook cost $55 that mom has to write a check for that? Just negative 55. So the checking account is going to go down 55. And what is the checking account going to do after she writes another check? Going to go down 75. So that's this first question. Now it says, do you see that then? Now we have to write an inequality. How do we want to write it? Well, let's write negative 55 is what compared to negative 75? Is it larger or smaller? It is larger. And we're done. All right, so let's go ahead. I'm going to go ahead and skip ahead. We're going to take a look at page 105, lesson 11. On lesson 11, we are going to take a look at example 1. Okay, so we're going to look at example 1. And example 1 says, the absolute value of 10 is written as two straight lines with a 10 in the center. Okay, on the number line, count the number of units from 10 to 0. How many units are there? Well, what did we come up with? We've done this before, right? It's 10 units. And then it says, what is another number that has that same absolute value? Well, if positive 10 is 10 units, what else is 10 units? Yeah, we got it, negative 10. So what other number? Negative 10, absolute value of negative 10. Now, make sure that our absolute value symbols are a little bit taller. It's not a scribble war, okay? So if you wanted to, you could maybe make it a tad bit thicker so you could see it better, but we need to make sure that we have vertical lines with negative 10 a little bit smaller inside, okay? And why is that the same? It is the same units, or number of units, I should say, number of units from, good, 0. Perfect. Absolute value of a number is the distance between the number and 0 on the number line. Next problem. All right, as we take a look at this one, it says the number 6, okay, the number 6, and we need to fill in the absolute value. So we're going to go absolute value of negative 6, and what is it? 6. The number on the number line, ready? We're going to graph it. So we know that negative 6 is here, and it's how far from 0? It is 6 units. So the different number with the same absolute value. So if this one was a positive or a negative 6, and it came out 6 units, what would it be on the other side? Positive 6. Next number. Absolute value of 8 is 8. Let's go ahead and graph that on our number line. Oops, I went too far there. And it's 8 units. So we need to say, what would be that same number, that same absolute value, but going the other direction? Absolute value of negative. Oh, goodness, negative 8. And they actually don't even want this symbol here yet. They just want us to say the opposite, negative 8. Negative 1, absolute value of negative 1 is 1. We'll go ahead and mark that. And the same value, or different number with the same absolute value, is just going to be positive 1. All right, let's go ahead. Example 2. Mrs. Owens received a call from her bank because she had a checkbook balance of negative $45. What was the magnitude of the amount of overdrawn? Now, magnitude is just the measurement in absolute value. So there is no positive or negative in the magnitude. So as we take a look at this, so absolute value of negative 45 is just how far away from 0, which is 45. So she overdrew her account by $45. Number 4, for each scenario below, use an absolute value to determine the magnitude of each quantity. Maria was sick with the flu, and her weight change as a result of it represented by -4 pounds. How much weight did she lose? So how do we write it? -4, and that equals 4. So our answer then, Mary lost 4 pounds. Notice we don't have a negative there. Jeffrey owes his friend $5. How much is Jeffrey's debt? Absolute value, he owes, so it's a -5, which is just +5. So Jeffrey has a debt of $5. Notice how we write it. Number 6. The elevation of Niagara Falls is located between Lake Erie and Lake Ontario is 326 feet. How far is this above sea level? Absolute value. 326 is 326. So Niagara Falls, ugh, rough day, ugh. Niagara Falls is 326 feet above sea level. All right, skipping to number 8. Okay, I'm skipping down to number 8. Number 8 says, Frank received a monthly statement for his college savings. It listed a deposit of $100 as plus 100. It listed a withdrawal of $25 as minus $25. The statement showed an overall ending balance of $835.50. How much money did Frank add to his account that much? How much did he take out? What is the total amount Frank saved for college? So we needed to, because the directions said we needed to write it as an absolute value. So let's go ahead and write absolute value of 100 is 100. Okay. And he added $100. And then absolute value of -25 is just 25. And he subtracted $25. And then our absolute value of $835.50 is just $835.50. And what is the total amount he has saved for college? He has saved $835.50. So literally, it's not difficult, guys. We're just trying to make sure that we know how to write them as an absolute value, and notice that they always come out positive. All right, let's go down to number 10. List a positive and a negative number whose absolute value is greater than 3. Justify your answer by using a number line. All right, so I'm going to do this, a number line, and I'm going to have a 0 here. I'm going to have my 3, and then obviously my -3. And we need something that's greater than 3. So what number is greater than 3? Let's pick it. Perfect. 5 is greater than 3. So I'm picking 5. And what then? Absolute value of 5 is 5. And what is my negative number then that corresponds with that? Well, my absolute value of -5 is also 5. So there we have it. And we can write now that 5 is greater than 3. Let's look. Next page, number 11, or next question, I should say. Which of the following situations can be represented by the absolute value of 10? Absolute value. Now, reminder, absolute value of 10 could be a positive 10 inside, or it could be a negative 10 inside. Remember that. You might also see it written like this. That means a positive or a negative. Either way will come out as a 10. So the temperature is 10 degrees below 0. Express this as an integer. That would be like that, right? This one says determine the size of his debt if he owes 10. That would be this way, right? Determine how far this is from 0. And 10 degrees is how many degrees above 0? Now, this is the question, though. We need to know if they can be represented by the absolute value, okay? If I'm just writing this as an integer, if they want this as an integer, I'm not writing the absolute value. So that one doesn't work. How much does he owe? Do we need to know that it's a negative or positive, or just how much? Yeah, we can write that as an absolute value, so that would be a yes. How far is this from 0? They just want to know how far it is, so yes, that's an absolute value. And this one, how many degrees above 0 is that? Just how far, right? So yes, so the bottom 3 should be checked. That top one, it literally wants to know it as a negative 10, so we have to leave that alone. Any other questions? Make sure you come and see me, and we're going to head back to the classroom.